This is Unit 12, Lesson 6. In Lesson 5, we learned about something called the law of sines, which is how the sine function can help us to find the sides or the angles in a non-right angle triangle. And this is the law of cosines, where we can use the cosine function to help us find sides or angles in a non-right triangle. So there are 3 different versions of this law of cosines. So pay attention to the way the triangle is labeled. We have capital letters denoting the angles and then lowercase letters that are directly across from each angle. All right, so here they are. We have a squared equals b squared plus c squared minus 2bc times the cosine of a. So there are 3 different versions of this formula, and it's going to seem really complicated when I write all of them down, but I promise you that they're actually pretty straightforward once you understand one of them. So I'm just going to write them down, give you guys a chance to copy them down. Okay, so oftentimes people see these 3 formulas and their brains automatically go into a panic because they seem so complicated and like, how could you possibly memorize 3 of them? But the trick is if you know one of them. So this is one of your sides. The other 2 sides go in this position. So you have like A, BC, B, AC, C, AB. These 2 right here are always the same 2 that are in these spots. So AC, AC. AB, AB. And then this angle right here, so it's always cosine, and this angle right here corresponds with the side that's over here. And it's a different letter than the ones that you have right here. So B and C, B and C, A. A and C, A and C, B. A and B, A and B, C. Same C that's over here, same B that's over here, same A that's over here. All right, so really, if you just know the pattern, if you know how one of them works, you know the rest of them. All right, so we can use these in 2 specific cases, which are different than the cases where you use the law of sines. So law of cosines you use in the side angle side case, which is specifically 2 sides in the included angle, meaning the one that's in between. So you might have little a, little c, and capital B, for instance. That is a side angle side case. Or you might have 3 sides. You might have side A, side C, and side B. My pen tapped this and it kind of made it look like a D, but I promise that's an A. So law of sines, you have to have a pair in order to use it. You either have to have side A and angle A or any of the other 2 pairs as well. With the law of cosines, you actually don't have a pair. Okay, so you have either all 3 sides and no angles, which means you can't possibly have a pair, or you have 2 sides with the angle in between, which would not be a pair either. All right, so that's how you know, and the next lesson we'll get into more detail, but that's how you know whether you're going to use the law of sines versus using the law of cosines. All right, so we are going to do the odd problems on the next 2 pages, so starting with number 1. The directions here say find each missing measure, round all answers to the nearest 10th. So we're going to be looking for this side right here. So setting up the law of cosines, we're going to be plugging everything into this piece right here. So x is the value that we're missing. So we are going to say x squared is equal to, you take the other 2 sides, square them, and add them together, equals, so 23 squared plus 9 squared, minus 2 times the other 2 sides, and then the cosine of the angle that's the opposite of this side right here. So times the cosine of the angle that is the opposite of that sine. Okay, so you get all this plugged in. Now here's the beautiful thing. X is what you're solving for. It is already isolated on the left-hand side of the equation. So you're just going to plug all of this into a calculator. Okay, so I'm going to pull open Desmos and walk you guys through what we're doing. Quick reminder right here, this little wrench up at the top here, look down at the very bottom, radians versus degrees for right now. All these problems are going to be in degrees. If they mention that an angle is given in degrees, you want to make sure that this is green on the degrees. Otherwise, you'll get all the wrong answers. You do not want to learn that lesson the hard way. So I am plugging in what I have right up at the top of my screen here, and you can plug it all in at once. So 23 squared plus 9 squared minus 2 times 23 times 9 times the cosine of 71 degrees. We type that whole thing in. You do not need to do it piece by piece when you're solving for a side. So we write this down. Let's say 4 decimal places while we're still in our intermediate step. So 4 decimal places equals 475.2148, and that is equal to x squared. Last little thing we need to do to solve for x is just to take the square root of both sides. All right, so typically when we're solving an equation with a square root, we always do a plus or minus, but this is geometry, right? We're talking about side lengths, so we know the side length is going to be positive. So I just take the square root of that number, 475.2148, and then this is the answer you round to the nearest tenth. So that 0.799 means it's going to round up to an 8. So 21.8 would be your missing side length. Okay, so that makes sense, kind of relative to all of these pieces right here. Right, so 9 is the shortest, which means that's the smallest angle. 23 is the biggest, which means that's the biggest angle. These are very close, which means these angles are going to be very close. All right, let's do number 3. So number 3, they give us the measurements rather than giving us the picture. So let's sketch everything out. So 106 degrees. That is this angle measurement right here. AB would be 10. So let's say this is A, this is B. Be 10, and BC would be 7. So that is this measurement right here. So this is a angle side setup. We want to find AC, so that is this measurement right here. Okay, so we're going to set up the exact same formula. Notice I mentioned these at the beginning. I told you don't really necessarily need to memorize each one individually. You just need to know how the pattern goes. So our missing side squared is equal to the other 2 sides squared and added together minus 2 times the other 2 sides times the cosine of the opposite angle to the one that's missing. So that is what your setup looks like. It's the exact same setup as we had with number 1. And just like number 1, we're just going to plug all of that right into a calculator. We do not need to do it piece by piece. So I'm plugging in what's up at the top of the screen there. So 10 squared, whoops. Oh my goodness, sorry. Plus 7 squared minus 2 times 10 times 7 times the cosine of 106 degrees. So we want to keep about 4 decimal places, so 187.5892. And then we solve by taking a square root. So square root of both sides, we really only need the positive one because we're talking about a side length. Okay, so round to the nearest tenth, that would be 13.7. Okay, so that's how you find a side. That's the side angle side case. Let's move on to our next type, which is finding angles, and that is if you have all 3 of the sides. So let's do number 5. We have all 3 sides. We have 5, we have 13, we have 16. So now the order that these go in is very important because pay attention here. If I'm trying to solve for one of the angles, we need to make sure that the opposite side is over here. Okay, so when we set this up, I'm going to just put it right under my formulas like this. So x is the one we're solving for, so 16 is the opposite side. That's the one that needs to go in. Oops, this is not even on the screen. I'm so sorry. This is the one that needs to go in this position right here because this is the one I'm looking for. This needs to be the opposite side. So I do 16 squared equals, the rest of the pattern goes the same way. The other 2 sides squared and added together minus 2 times the other 2 sides times the cosine of that missing angle. So that is where the x degrees goes right there. Okay, so this is what we're trying to solve for. This is going to be a little bit trickier than the ones on the previous page because we don't just get to plug everything straight into the calculator. We do actually have to break it apart piece by piece. Okay, so I'm going to plug in 16 squared. So that is 256. And then I can do the addition here. I can do 13 squared plus 5 squared. That is 194. Minus, and then I can do this, 2 times 13 times 5. Oops, I want a different piece there, sorry. That is 130 and then times the cosine of x. So here's something very, very, very important. Do not subtract those two numbers. This is attached to the cosine of x, which means those guys are kind of a package deal. You need to solve for this guy right here as if that's your variable. So start by subtracting the 194. So we'll do 256 minus 194. That gets you 62 equals negative 130 times the cosine of x, and then divide both sides by negative 130. So 62 divided by negative 130, that gives us negative 0.47692. It's a 9 right there. That is the cosine of x. Remember, just like the last few lessons, if this is what you're solving for, you do the inverse cosine of this number right here. So we do cosine inverse to get our answer. So inverse cosine, and then we plug in this value, which I have right here, negative 0.47692. The more numbers you plug in, the more accurate this will be. So round to the nearest tenth, we get 118.5. Okay, so that is what it looks like when you have all three sides and you want to solve for an angle. We're going to do a couple quick applications of this stuff. So read number 7. Maple Street, Oak Street, and West Avenue intersect to form a triangular piece of land. So we have 3 different streets intersecting. So Maple Street, Oak Street, and West. The angle formed by Maple Street and Oak Drive is 79. So let's call this Maple Street, Oak Drive, 79. If the Maple Street section of the triangle is 390 feet, and the Oak Drive section is 250 feet, find the length of the West Avenue section. So let's go W for West. So those are all the pieces that I can set up. When we're doing a missing side, that is a lot easier. This is our side angle side case. So we just use the formulas from the front right here. Okay, so our missing side goes in this spot right here. So that will be W squared equals, take the other two, square them, and add them together, minus 2 times the other two sides, times the cosine of the opposite angle, so times the cosine of 79 degrees. Now, in this side angle side case, when I'm looking for a missing side, I just get to plug this whole thing into my calculator, and I will do that. So what's up at the top of the screen? I'm going to plug in. I have 390 squared plus 250 squared minus 2 times 390 times 250 times the cosine of 79 degrees. So all of this right here, I'm going to write down 177,000, etc. So W squared is 177,392.2459. And that's W squared, so I just have to take the square root, and that will give me my answer. So take the square root of that number up above. Okay, so round to the nearest tenth, I get 421.2. And that is in feet because it's a story problem, and the other ones were given in feet. All right, one last example here, number 9. 2 radar stations 2.5 miles apart are tracking an airplane. The straight line distance between station A and the plane is 7 miles. Okay, so station A and the plane is 7 miles. The straight line distance between station B and the plane is 9 miles. So this is obviously not drawn to scale. What is the angle of elevation from station B to the plane? All right, so from station B to the plane, that elevation would be this measurement right here. Okay, so that is our missing piece. So from angle B to the plane, that's our measurement. So we're looking for a missing angle. So when we set up that formula, just like we did up above, this spot has to be the one that's across from the missing angle. So we use the 7 in our first spot. So it'll be 7 squared equals square the other two sides and add them together, minus 2 times the other two sides times the cosine of that missing piece. So we actually are going to plug these things in piece by piece. So 7 squared is 49 equals 2.5 squared plus 9 squared is 87.25 minus 2 times 2.5 times 9, which is 45, times the cosine of x. This is a package deal. Do not subtract those two numbers. We need to get this guy by itself, which means we're going to start by subtracting the 87.25. So I'm going to do 49 minus 87.25. I will get a negative 39.25 on the left, negative 45 times the cosine of x on the right. Divide both sides by negative 45. And I get this, so 0.87 and then a bunch of 2's is equal to the cosine of x. Remember, when I have the cosine and I need the angle, I do cosine inverse, and that will lead me to my angle. So cosine inverse of 0.87222. So round to the nearest tenth, that is 29.3 degrees.